Okay, so the first question I gave you here was 3 to the power of 2x equals 24 minus 5 times 3 to the power of x. Now you need to recognize, you should recognize that this is a quadratic equation. So we did a number of these when we were doing our logs chapter, and there's nothing on the course that looks similar to this. So you should recognize from your first line that, right, I've clearly got a quadratic equation here. Now the only way to form your quadratic is you have to do substitution. So in this scenario, I'm going to sub in, instead of 3 to the power of x, I'm going to sub in y. So you should indicate that at the start. You should indicate that, right, I'm going to let y equal to 3 to the power of x. Which means if you look back at your equation now, the right-hand side is very straightforward. The right-hand side of this equation will just become 24 minus 5 times, and instead of this, I can put in a y. So my right-hand side is grand. I've got no unknown in my powers, so there's no problems there. However, the left-hand side is still a problem. On the left-hand side, I have 3 to the power of 2x. Now, the first thing you should do is split up your 2x. Rather than writing it as 2x, you can write it as 3 to the power of 1x plus 1x, or just x plus x. And at this stage, you need to use one of your rules of powers. Your first rule of powers says that a to the power of p plus q is equal to a to the power of p times a to the power of q. So with that in mind, I can say that 3 to the power of x plus x is the same as 3 to the power of x times 3 to the power of x. Now, at this stage, I've stripped down the term on the left so that it looks like my substitution. So now I can just sub in. Instead of 3 to the power of x, I can put in a y, and the same with this one. So it just becomes y multiplied by y. Or in other words, I've now written 3 to the power of 2x as y by y, which is y squared. So I can come back to my equation, and my left-hand side just becomes y squared. Now at this stage, you have a y squared, you have a y, and you've got a number. If you have a y squared, a y, and a number, you should recognize that it's a quadratic equation. So you need to bring everything to one side. So let's bring everything to the left here. We'll get y squared plus 5y minus 24 equals 0. So you need the factors of 24 that have a difference of 5. There's a minus at the end. It's the factors of this number that have a difference of 5. So the numbers that multiply to give you 24 with a difference of 5 are 8 and 3. Which means I'm just going to rewrite this line, except instead of writing this as 5y, I'm going to write it as plus 8y minus 3y. So plus 8 minus 3 will give me plus 5y. So I haven't actually changed the value of the expression. I'm just writing it in a different form. And now I can just do my factorizing by grouping. So what's common to the first two is just y. So if I take out y, I'm left with y plus 8. What's common to the second two is minus 3. If I take out minus 3, I'm left with y plus 8. I have the same thing in both brackets, so I know I'm on the right track. So my factors here are just y minus 3 times y plus 8. So y minus 3 times y plus 8 equals 0. But obviously I've got no interest in my factors at the moment. I need to continue on and get the roots of this quadratic. So I can let each factor equal to 0. I can say that y minus 3 equals 0 and y plus 8 equals 0. So to get y on its own, I'll bring my 3 to the other side, and I'll get y equals plus 3. To get y on its own here, I get y equals minus 8. So I got y equals plus 3 and y equals minus 8. But clearly, the y is no good to me. The question didn't ask me to find y. I just made y up at the start of the question. The question was to find x. So clearly the original equation had an x in it, so I need to find the value of x. And don't forget to go back and find your x. So in this scenario now, I should continue on. I know that y equals 3 to the power of x. So I can let 3 to the power of x equal to both of these answers. So I can say that 3 to the power of x equals 3, and I can say that 3 to the power of x is equal to minus 8. Now, 3 to the power of something will never be negative, so at this stage you can just cross that one out. And I have 3 to the power of x equals 3. Now, in the leave insert, usually when your unknown is in the power, you're going to have to introduce logs. But obviously in this case, we can actually tell the answer is a whole number, so in this case I can actually do it in my head. If 3 to the power of x equals 3, I could just view the right-hand side here as 3 to the power of 1. And I can say that 3 to the power of x equals 3 to the power of 1, so my final answer here is that x is equal to 1. So usually in these questions, when you get to this stage, your unknown is in the power, you'll have to introduce logs. But when your answer is one that you can do in your head, you can just do it like this. The second question on the worksheet here, you're just asked to simplify this and write it as a single fraction. Okay, now this kind of thing has been coming up a lot the last few years in mock papers. You should never divide one fraction by another. So straight away, the first problem you should recognize here is my divide sign. If you've got one fraction, you don't want to divide it by another one. So instead of dividing by a fraction, you can invert it or just flip the fraction and multiply. So the first thing you should do is rewrite this as x plus 4 over x squared minus 16. Change this to a multiply sign and invert your fraction. So it becomes x squared minus 25 over x minus 5. And at this stage now in these questions, you want to factorize as much as possible, and hopefully a lot of it will cancel out. So x plus 4 on the top of this fraction, there's nothing you can do with that. They're not like terms. I can't factorize any further. But x squared minus 16, this is the difference of two squares. The square root of x squared is x, and the square root of 16 is 4 and 4. One of them's a plus, one of them's a minus. I can do the same on the top here. I'm multiplying by the factors of x squared minus 25 are x minus 5 times x plus 5 over, and the bottom of that line is just x minus 5. And once you've factorized everything, then usually a lot of things will cancel out. So here my x plus 4 on the top and my x plus 4, the way you should, mathematically the way I should be saying it is that x plus 4 divides into x plus 4 once, so this just becomes a 1. The x minus 5 divides into this once, so that becomes a 1. And don't forget to write your very last line. So the very last line has to be what you're left with. On the top, I'm just left with 1 times x plus 5, so I'll just write that as x plus 5. And on the bottom, I'm left with x minus 4 times 1, so that's just x minus 4. So my final answer is x plus 5 over x minus 4, and I can't factorize that any further, so that's expressed as a single fraction. Okay, so the third question I gave you here was x plus 1 over x to the power 6, and you're asked to find the term independent of x in the expansion. Independent of x means the one where there's no x's, the x's cancel each other out. So the first thing you should do is list them all out. So you'll notice that I've done that here. First of all, if there's a plus between them, then that means every single term will be a plus. If there's a minus between them, then every second term is a plus and every second one is a minus. But because that's a plus, I know they're all positive. If I'm using the binomial expansion, it's 6 choose 0, 6 choose 1, 2, 3, 4, 5, and 6. So altogether you should have 7 terms. So I'd start by listing out maybe those numbers. Then you get the first term, which in the first thing in the brackets is x. So it's x to the power 6, 5, 4, 3, 2, 1, 0. And then you go backwards with this one. 1 over x to the power 6, 5, 4, 3, 2, 1, 0. And that allows you to come up with all of these. So I think your best bet here is to actually just list them all out first. And at this point then you should take a step back and try and figure out which one is going to be independent of x. If you're not 100% sure, there's no harm in trying a few of them, try and simplify a few of them, because you'll figure out pretty quickly whether they are independent of x or not. But in this case, the one that we're looking for is this one. 6 choose 3, x to the power 3 times 1 over x to the power 3. Because, right, so let's just write it. So this is the only term I'm concerned with now. It's 6 choose 3, x to the power 3, 1 over x to the power 3. That's the same as 1 cubed over x cubed. It's like cube in the top and then cube in the bottom. So what I want you to notice here is, if I simplify this further, 6 choose 3, you can put that into your calculator. 6 choose 3, you get 20. You should view this maybe as x cubed over 1. And 1 by 1 by 1, clearly the top of that just becomes a 1, and the bottom is x cubed. So you could view that as x cubed over 1 by 1 over x cubed. If you have an x cubed on the top and an x cubed on the bottom, they're going to cancel each other out. Which means, or I should say, they're going to divide. X cubed into x cubed goes once. So that means this term is independent of x, and if you simplify out that term, you just get 20. So your final answer in that case is 20. Okay, so the next question I gave you here was a simultaneous equation. Remember, there's 2 types of simultaneous equations on the course. If you have 3 equations and 3 unknowns, you can solve it. We're just doing the same method as we did at Junior Cert. The other type then is if you have 2 equations, 2 unknowns, and one of them is a squared, then you have to do it by substitution. But in this case, if you have 3 equations, 3 unknowns, you can find x, y, and z. So you'll notice here, the most important thing is that you just have a structure. So it's really important to label each of your lines. So I've labeled these as A, B, and C. And what I decided to do was get rid of my x's. So the first thing I did was I multiplied the line A by -2, and then I wrote it beside line B. So if I multiply everything on the line A by -2, I get -2x minus 16y plus 3z equals 2. And B is 2x minus 3y plus 2z equals 2. And at that stage now I can just add these 2 lines together because my x's will cancel. -2 plus 2 is 0. Minus 16 minus 3 gives me minus 19y. Plus 6 plus 2 gives me 8z. And 2 plus 2 gives me 4. So I have a new equation with only two unknowns. So I'm going to call this equation D. And I'm going to do the exact same thing now. I'm going to take two other equations and try and get rid of my x. So I decided to take equation B and equation C. And in order to get rid of the x's, I needed to change the signs of one of them. So I'm changing the signs of B. It becomes minus 2x plus 3y minus 2z equals minus 2. And C is 2x plus y plus z equals 5. So when I add these two lines together, I get minus 2 plus 2 is 0. 3y plus 1y is 4y. Minus 2z plus z gives me minus z. Minus 2 plus 5 gives me 3. So that I'm going to call this equation E. It's a second equation with only two unknowns. So now you'll notice that at this stage, with equation D and equation E, I'm right back to junior cert simultaneous equations. I have two equations, two unknowns, so I can solve it. So I looked at this and realized the easiest thing to get rid of is the z's. If that's an 8z and that's a minus z, I decided to multiply the line E by 8. So I've taken the line D and 8e. So D is minus 19y plus 8z equals 4, and 8e is 32y minus 8z equals 24. Now when I add my two lines together, 8z minus 8z is 0, minus 19 plus 32 is 13y, and 4 and 24 is 28. So 13y equals 28, that means that y is 28 over 13. So just be aware you can get very awkward answers like that. So I wanted to go through this one because sometimes the answers are very awkward. So now that we've found our y, I'm going to sub back in here and I'm going to find the value of my z and then find the value of my x. Okay, so I started up over here. We now know that y is 28 over 13, so if we take equation E, we'll be able to work out what z is. So instead of my y, I subbed in 28 over 13, and I simplified it down, and I ended up with z is equal to 73 over 13. Once you know your y and you know your z, you can sub back into one of your original equations to find your x. So I sub back into my equation A, which was x plus 8y minus 3z equals minus 1. I subbed in my value for y, my value for x, simplified it down, and I got x is minus 18 over 13. So my final answer there is, this is my x, this is my y, and this is my z. But now obviously, in an exam, if you start getting answers like that, you're going to be second guessing yourself. So there's no harm in going back to one of your other equations and just double checking that it works. So I went back to my equation B and I subbed in my x, my y, and my z, plugged it all into my calculator, and I ended up with 2, which was what I was meant to end up with. So I ended up with 2 equals 2. So at least in an exam, that'll calm your nerves. At least if you get a really awkward answer, you can double check and you'll know if you're right or you're wrong. Okay, then the next question now, you're given a cubic equation and you're asked to solve. Okay, this has come up as an entire short question in the Leaving Cert. Just given a cubic and you have to find the 3 roots. When you're given a cubic and you're asked to solve, basically to find the first root, it's just trial and error. So the first thing you should try is x equals 1. If x equals 1 is a root, that means that when you sub in 1, the whole thing will be equal to 0. So in this case, when you sub in 1, it doesn't work out, so x equals 1 is not a root. If that one doesn't work out, then you try x equals minus 1. In this case, when you sub in minus 1, that one doesn't work out either, so then you try 2. When you did 2, that one doesn't work out either, so then you try minus 2. So you just have to follow this system the whole way along. But for us, the one that's going to work is x equals 3. When you sub in x equals 3, you get 2 times 3 cubed minus 9 times 3 squared plus 2 times 3 plus 21 equals 0. You're going to get, so that's 54 minus 81 plus 6 plus 21 equals 0. So you get 81 minus 81 equals 0. Now, people often lose marks because they don't conclude these ones. So I want you to go fully. End up with 0 equals 0, and you put a tick beside it. Therefore, x equals 3 is a root. So I want you to make sure you do your conclusion as well. You need to be thorough with those ones. Now that we know the root, we can continue on and find the other 2 factors. Okay, so to finish this one off, I need to find the other 2 roots of this cubic. So if I use my minus b formula, I subbed in my a was 2, my b is minus 3, and my c is minus 7. So I finished this one off, and I ended up with x equals 2.77 and x equals minus 1.27. So the question said to solve the cubic, and we've now found our 3 roots. So the very last thing you should write down are the 3 roots. And make sure you write them in the form of roots. So the roots of this cubic are x equals 3, x equals 2.77, x equals minus 1.27. So when it asks to solve, solve means find the roots or find the value of x. and my 3 roots in this case are there. Okay, so the final question here, I think this is clearly the most difficult thing that we've gone through so far, and it will be the most difficult thing on the test. Right, so I'm told that this quadratic is a factor of this cubic, which implies the remainder must be 0. So I'm going to divide this into this, and I'm going to get a really, really messy remainder, but I'm going to be able to let it equal to 0. And when I do that, I'll hopefully be able to prove that A is equal to minus 6 over B minus 2B. Now, to do our long division here, it's the exact same as the last question. The first step is always to divide. So take the first thing here and you divide it into the first thing here. X squared into x cubed is x. Second step is to multiply. You're going to multiply what you put on top by all 3 of these. X by x squared is x cubed. X by ax is plus ax squared. X by minus b is minus bx. And now you want to change your signs and you want to subtract. So that becomes a minus, that becomes a minus, and this becomes a plus. My x cubed will cancel, and it's at this stage that you need to be careful. You're better off to do this in your rough work. So you have minus 2bx squared minus ax squared. It's mathematically accurate to write that there. It makes sense, but it'll make the question very, very difficult. You're much better off to factorize out your x squared. So write this as minus 2b minus a times x squared. So the x squareds here become minus 2b minus a times x squared. You want to do the exact same thing with this. You have ax plus bx. You want to factorize out your x, and you're left with a plus b times x, which means that this becomes a plus b times x. And then the fourth step in our long division is you want to take down the next term, which is a minus 6. So I've done it all once, and I've no more terms to take down. So that means I have to do it all once again. I have to do the whole process again. X squared into minus 2b minus a times x squared. Well, x squared into this will go once. X squared into x squared goes once. So you're just left with minus 2b minus a. That's your first step. Your second step is multiply. Multiply minus 2b minus a by x squared, and you'll just get minus 2b minus a times x squared. Multiply minus 2b minus a by ax, and you'll just get minus 2b minus a times ax. So notice how I'm not bothering to multiply at all there. I literally just list them out. Multiply minus 2b minus a by minus b, and you're going to get minus b times minus 2b minus a. So again, I'm just listing it out. I didn't bother to multiply anything. My third step is to subtract. So this becomes a minus, this becomes a minus, and this becomes a plus. And now I just want to add my lines together. My x squareds will cancel, and you need to recognize that at this stage you're at your remainder. I know that I'm at my remainder because I'm not going to be able to take down another term. You need to split your remainder into 2 different remainders. The first remainder are the coefficients of x. The coefficients of x must be equal to 0, and the constants at the end must be equal to 0. So the coefficient of x on the top line is a plus b. And the coefficient of x on the bottom line is minus times minus 2b minus a times a. So that one's messy. It's minus times minus 2b minus a times a. And I know that that is equal to 0. So the coefficient of x on the top and minus the one on the bottom equals 0. If I do the same thing over here, the constant on the top is minus 6. And the constants on the bottom is plus b times minus 2b minus a. And I know that that is also equal to 0. Now, usually you'll have to use both of these equations. But in this case, we actually don't. Because notice there's an a and a b in this equation, and there's an a and a b in this equation. So both of my equations have the right constants, or the right variables there, my a and my b. So you need to ask yourself now, which one of these equations is likely to get you to this equation? And I think the giveaway there is the fact that there's a 6 in your answer. If there's going to be a 6 in your answer, the chances are you're going to need to use this one. Now, you might not have to use that one, but your intuition there, you should probably see if there's a 6 there, then hopefully this one, I'm more likely to get to my answer by using this one. So if you haven't gotten this far, I want you to pause the video, see if you can do that yourself. Use this equation to isolate your a and see if you can get to your answer. And I'm going to wipe this off and then start from the top. Okay, so my second remainder equals 0, and hopefully that is enough information for me to get to this point. So if you look at your answer, you clearly need to isolate your a. Now, before you even think about isolating your a, you need to worry about what is the immediate complication. The immediate complication in this case is the brackets. So you should multiply it out. b by minus 2b is minus 2b squared. b by minus a is minus ab. Okay, so I get minus 6 minus 2b squared equals minus ab. Now clearly you need to isolate your a. So you should try and isolate this term. So let's say we could just bring that term to the other side. I'll get minus 6 minus 2b squared equals plus ab. Again, I'm trying to isolate my a. So in order to get a on its own here, I would have to divide this term by b. But if I divide that term by b, I'd have to divide every term by b, because you can't just randomly pick one term and divide it by b. So I'm going to divide everything by b. Minus 6 divided by b is minus 6 over b. Minus 2b squared divided by b is just minus 2b. And ab divided by b is just a. And if you notice from there, then that is what we were trying to get to. That's exactly what they asked me there. So there will be a question like this on the test. So I want you to make sure you watch this video and watch the previous one from the Halloween revision worksheet and practice a couple, because I know they're quite difficult.